All right. Thanks, Kelly. Um, we're here in the DGen Valley podcast studio. We're going to do a demo for you guys today. Uh, the demo that we're going to launch today is a demo of about 10% of the full network capacity of Silvermint. We're gonna start off by showing you the quiescent network, and then we're going to launch it in the Google Cloud and let it come up to speed while we talk a little bit about Silvermint and our motivation and our advantages. Then we're going to walk through the demo network with you, talk about performance, what you're seeing on the console, what you can expect from it in terms of deployment and efficiency and that sort of thing. And then we'll wrap up with some more discussion of our future roadmap and objectives and why we think Silvermint's a compelling project. So this is our demo console. So our SRE Rusty, who's on mute right now, is going to launch our cluster. The cluster that we're working with right now has about 100 validators in it. It's deployed in Google Cloud. We are using Terraform to do deployment coordination so that we're currently able to spin up an entire network on demand, which you'll begin to see data flow in here. We use Prometheus to share metrics with our graphics console, which is based on the Grafana technology. Much of this is going to be available for the production Silvermint network. And so as we build out production Silvermint, validators and node operators will be able to integrate with regional and global consoles so that node operators in the world can see real-time metrics about the operation of the network and keep track of how things are going. The machines that we're deployed on right now are Google's N2 standard 32 nodes. Those virtual machines have 32 cores of CPU, about 512 gigs of RAM. So they're very affordable, relatively inexpensive machines. I think that the unsubscribed, like if you purchase them with no reservation and no long-term commitment, cost for these nodes is about $1,500 a month to run. We anticipate that the production nodes will have higher hardware requirements, but this is should give you a good sense of sort of what kind of a range things are going to be in when we actually hit production. This demo is currently set up to generate actual real world looking traffic. So we've got 100 nodes, and each of those nodes has a traffic simulator that's pointed at it. The traffic simulator starts out at the very beginning by minting a bunch of wallets and creating a bunch of coins, and then periodically sends transactions between wallets on the node so that you can actually see how payments would work. And as the wallets accumulate dust, the simulator will perform sweep transactions to sweep up the dust into larger coins. And the result is that what we're going to get here is a pretty realistic approximation of what real world traffic will look like. This demo is configured to send transactions to each validator at a rate of about 120 to 130 transactions per second. There's some randomness built into the simulator, and so it won't be exactly any particular number, but it's going to be in that range. You could see on the console, we've already got the 100 nodes are online. We haven't yet begun receiving transactions because initially when the nodes first come online, all that's happening is that wallets are being created and coins are being minted into those wallets so that we can simulate payments. But you can see it's already been running a minute. We've already produced 5,500 blocks, which is approximately 1 block per second per node. And this is exactly what we'd expect. And you can see the transactions are starting to come online now. Network bandwidth is up, and so these numbers will grow over time and then eventually stabilize around the peak transactions per second that we've got configured. So we want to switch back to the slide deck. We can talk a little bit more about Silvermint um, while the network's coming online. So I think a big question that we get is, why do we need something like Silvermint? Um, here we imagine a new era of financial empowerment for everyone, and we've made it our mission to unite people and create opportunities for everyone in the world, um, to use blockchain technology to change the way that finance works in the world today. But unfortunately, current blockchain solutions simply don't scale. There's around 2 billion people in the world currently that are unbanked, and there isn't a single blockchain solution that can provide them with the kind of throughput at the kind of cost that would be necessary for them to be able to do their daily commerce. Um, on top of that, we think that centralized finance profits are out of control. Banks and financial institutions, financial networks have too much control over the flow of capital. They have too much of an ability to charge fees, and that creates high costs for end users, security risks, privacy risks. And the result is that, just generally speaking, it's often no longer worth it for many people. Even here in the United States, many banks and traditional financial institutions have begun talking about what they call balance sheet leakage, which is the movement of assets from traditional banking institutions and financial institutions to non-traditional or alternative financial institutions, which can be PayPal and Venmo and Cash App, but can also be Coinbase and um, you know, other exchanges and cryptocurrencies and Bitcoin in general, and things of that nature. Um, what we want to do with Silvermint is we want to build a network that's fast enough for everyone to use for global commerce, that's cheap enough that everyone can use it, and that's decentralized enough so that everyone can trust it. That's the main motivation for us. That's our mission, and that's what we think makes Silvermint particularly special in the space. Next slide. So our technology stack has a variety of advantages over other layer one networks. The first advantage is the consensus protocol that we've designed called Casanova. It's completely unique in the space in that, rather than involving choices between different block production forks, or what's called in the industry a fork choice rule, or voting on fork choice, Casanova is a DAG-based consensus algorithm where every node in the network produces blocks all the time, and those blocks are always accepted as long as the validator isn't equivocating. That makes Casanova optimized for scale in a way that's completely unique. When we deploy our root shard, which will have over 2,000 validators in it, we will be producing more than 2,000 blocks per second, which is over 100 times faster than the block production rate for a network like Solana. And as a result, we're going to be able to produce transaction throughput that's equally fast. As a result, Casanova is optimized for incredible speeds. It's also optimized to incentivize censorship resistance and to get node operators to add physical resources to the network. So the way that our staking works, and the way that that's distributed amongst nodes, means that node operators have to contribute actual physical resources. You can't simply contribute more and more stake with the same amount of physical resources and expect to earn more yield. They want to earn more yield, they have to buy more physical nodes and deploy them on the network, which is exactly what you want from a network that needs to scale to global commercial size. Silvermint solves the blockchain trilemma for the first time in the cryptocurrency era. We can offer the speed that is needed through an efficient protocol and incentives for adding physical resources and bandwidth when needed. We have the security necessary to allow transactions to be considered truly finalized, and we have true censorship resistance, and we have decentralization that exceeds anything available in the cryptocurrency space today, because we have equal stake weighting, and we have an excellent governance model for validator distribution. Silvermint's also built by developers for developers. We have put a singular focus into making the systems engineering for building out the network, that is building, deploying nodes, creating building the operating system and deploying the software onto it that's necessary to actually run and manage nodes. And our software is going to be the easiest to deploy, manage, and monitor of anything in the cryptocurrency space. We've also made it extremely easy for application developers to build on our smart contracting layer. Our smart contracting layer language is called Symmetry. It's based on Go, and it's incredibly easy to learn because it contains Go as a sublanguage. You can just write straight Go, and they're perfectly valid smart contracts. But it also includes highly advanced features such as a theorem-proving type system based on Microsoft C3 that makes it possible for your smart contracts to be extremely secure and provably correct. So you no longer have to worry about bugs in your code causing massive leakage of financial value. Slide. In comparison to other networks, I think our metrics stack up really well. Transactions on the Silvermint network are published to blocks within about 500 milliseconds, and they're truly finalized within 3 seconds. On our network, that means that they can never be rolled back. A finalized transaction on the Silvermint network is completely and forever finalized, not like probabilistic finalization as exists on most other networks involving fork choice. Compared to other networks, we feel like this is extremely beneficial. We can do about 140,000 transactions a second, which is about 40% faster than the next fastest network. And our Nakamoto coefficient is almost 700, meaning in order to compromise the root shard, someone would have to compromise almost 700 nodes before they could begin to even reduce the bandwidth that was available for transactions. In order to actually take over an entire shard, it would take close to 1,500 nodes to be compromised. Okay, so let's return back to the demo console. And at this point, it's been running for a while. I'm going to just talk through what you guys are seeing here on the console and give you a sense for what some of these different numbers mean. Obviously, in the top left-hand corner here, you see 12,100, which is the transactions being received every second. Those are actual payment transactions, unlike on a network like Solana, where they will claim that they're doing 20,000 transactions a second, but 75% of those transactions are what they call voting transactions, and only 1 in 4 are actual payments. This is a count of actual payments being made between wallets on the network. You can see that they're currently finalizing in about 3.74 seconds. That's an average. On some nodes, they're finalizing faster. Just depends on exactly how quickly blocks get received by the different nodes. The 3.74 seconds is a measure of the time between the timestamp in the block when it's produced and the time when the node reporting finalization actually observes that the network has completely finalized it. So that number, at that point in time, that transaction can never be changed, can never be altered, can never be rolled back. It's perfectly secure. The graphs to the right of those two numbers show you on a per validator basis what those different metrics are doing. And you can see that in this case, they're quite stable. Each node is receiving roughly the same amount of traffic. They're finalizing their transactions in about the same amount of time, which means that we've got a network that has the same rough utilization across all of the different nodes. Down below that, you can see on to the left there, you see finalized per second per node. You'll note that there's some variance here, and that basically is caused by blocks being received at slightly different times between the different nodes. Another thing to note is this graph just to the right there, which says pending per node. In most blockchain systems, the demand for transaction throughput significantly exceeds the capacity of the network to finalize transactions. And so networks have to queue transactions in what's typically called a mempool. That mempool then has to be shared around so that whenever another node produces a block, it can include whatever transactions from the mempool make sense. And that sharing of that mempool, usually via some peer-to-peer protocol, is actually quite expensive in terms of the network bandwidth and the computation that it consumes. Silvermint's throughput is so high, we don't have a mempool. As you'll notice here, the pending per node is mostly well below 100. Far more than 100 transactions fit in each block. And what this is telling us is that the transactions being received by each node are immediately being published in a block as soon as they can be. On average, what that means, since every node produces a block every second, is that transactions, if they're flowing in at an even rate, will take about 500 milliseconds to show up in a block from the time that they're actually received by the node, which means that users' transactions will appear on the network at about the same speed that a Google search query takes to render in your browser. We've been up for 13 minutes now, and you can see that we've produced about 75,000 blocks. The rate of block production is pretty stable. Memory and CPU are stable on our N2 standard 32s. We're only consuming about 10 of those cores, so we have plenty of capacity to grow the size of this network before processing transactions begins to overtake our CPU capacity. And our memory utilization is pretty good. We only have about 50% memory utilization consumed. You can see that our network consumption here at 12,000 transactions per second is about 3.5 megabytes per second on the upside, about a little bit less than that on the down. So, roughly 3.25 megabits per second. And that's exactly what we would expect. Our full production nodes are going to be expected to need to process about a gigabit per second worth of to have about a gigabit per second worth of bandwidth for capacity, and so these numbers look good. One of the things that I'd like to point out to you before we move on is this bottom right number, which is the percentage of the network traffic or the bytes in a block that are consumed by consensus finding data. Again, Silvermint's Casanova algorithm is based on a DAG, and it's the structure of the DAG that allows the network to figure out when transactions have actually finalized and when they haven't. That DAG structure information is all the information that the nodes need in order to perform finalization. So there's no voting or double checking or anything like that. At 12,000 transactions a second right now, that's only consuming about 6% of the total bandwidth. That's less than 10% of the bandwidth that Solana needs to achieve the same effect. Okay, so that's the basic console. As we scale this demo into testnet and then onto mainnet, our goal, this is doing 12,000 transactions a second, which is slightly less than 10% of what we want on about 5% of the total node count of what we expect for production. So we're going to be scaling it up to, we expect to get about 100,000 transactions when we're at about 1,000 nodes, and then to peak out around 140 or 150,000 transactions a second on 2,000 nodes. Depending upon how the network works, we may be able to burst periodically to higher transaction rates, but 140,000 per second is our expected peak capacity for the root shard, or sustainable capacity for the root shard. As you'll notice, that's not quite of a linear increase. We can't simply add a 0 to the number of nodes and get 120,000 transactions a second, but it's better than anything else that's out there today. Slide. As I discussed, we've spent a lot of time designing the Silvermint technology to be especially easy for systems engineers and SRE types to use. Our software is going to be distributed in a extremely standard way. Right now, we support Debian packages, but if you're running other versions of Linux, we'll eventually support RPMs and snaps and things of that nature. It's designed to be easily orchestrated, whether that's with Kubernetes or Terraform or whatever orchestration technology you're using. It's going to be easy for you to spin up your physical resources or your cloud resources, run the node software across those resources in a way it's fairly standard in today's infrastructure as code kind of environment, and then to be able to manage them successfully that way. We have internally built a fairly sophisticated CI/CD environment or continuous integration and deployment environment. We've used that continuous deployment environment to spin up this demo today, and we'll continue to use it as we open source the software. More and more of that CI/CD environment will become public information, so that you'll always be able to see where the latest version of the software is in terms of performance and feature sets that are being rolled out and that sort of thing. We've also designed the software to be extremely simple to use for reporting and production monitoring. As I said, we have built the Prometheus technology into the node software so that you can simply run a Prometheus node and scrape the node software to get metrics about how the internals of your node are working. You will also be able to publish if you're running multiple nodes, for example, you'll be able to publish your metrics up into a roll-up console that's available for everyone to use as a global diagnostic or regionally diagnostic tool for the production environment. We believe that these kinds of features are completely unique in the cryptocurrency space today, and we think that it's going to make it much faster and easier for us to create a highly decentralized environment that's also highly successfully managed from a systems engineering standpoint. We accomplished a lot of really important goals in 2022, including the implementation of the validator software and an initial version of Symmetry. Both of those are going to be released as open source software this quarter. In 2023, we're hoping to sign up the first few hundred validators, launch our public testnet, and prep for the main network launch, which is anticipated to be in Q4. Our demo environment already shows that Silvermint is faster than its closest crypto rival, Solana. Last quarter, Solana's test network finally hit 22,000 TPS, but 75% of those are voting transactions, meaning that their actual payment transaction throughput's only about 5,000 TPS. Since Silvermint doesn't use voting, our TPS rates are 100% actual payments, and our demo is therefore already 2.5 times faster than Solana's testnet. On top of this, Silvermint's managed to accomplish this with a staff of fewer than 20 people. Solana had to raise $300 million over 9 rounds to get 5,000 TPS. We more than doubled that with $3 million. We aren't just faster and more efficient network, we're a faster and more efficient team. And that's why you should take a look at Silvermint and join our community today. So when we say we want it all, you can take us seriously. Silvermint is going to be fast enough for the world to use it for global commerce, cheap enough for everyone to use it, and decentralized enough for everyone to trust it. In the late 1990s, the internet changed the world of publishing. Blockchain and cryptocurrency technologies are doing the same thing to the finance industry that the web did to publishing houses, newspapers, and magazines. Everybody can be a banker or a hedge fund manager or create financing opportunities in and between communities in their area. But to be successful, we're going to have to scale. The current crypto market capitalization is only $1 trillion, but global financial markets are worth more than $26 trillion. No crypto network in the world is fast enough and scalable enough to get us where we want to go. Silvermint's going to be the first. All right, well, thanks very much for joining us and have a good evening.